In this section, we're going to solve three types of multi-step equations. First, we're going to do it by combining like terms, which is pretty similar to what you did yesterday. Then we're going to solve multi-step equations using the distributive property, and then by using reciprocals. The most important thing when solving multi-step equations is that you need to simplify everything that you can on both sides first. This is the absolute most important thing. So you want to look for, are there like terms, can I distribute, what can I do on one side of the equal sign before I start to isolate my variable. So this is before you even start to isolate the variable. So if you just look at actually the first example, if you were to cover up, say, the equals 20, and that didn't exist, if you look here, you have like terms. You have 8x and 3x. So the first thing that you could actually do is do 8x minus 3x is 5x, and then you would just bring down your minus 10 and then your equals 20. That's what you want to do first. Once you've done that, you're going to solve like normal, which means use reverse PEMDAS, like we did yesterday, and then check your answer. And when you check, you always want to check in the original equation, in case you made a mistake along the way. So now that I've combined my like terms on 8x minus 3x minus 10 equals 20, I'm going to start to isolate x by adding 10 to both sides. So then I get 5x equals 30, and then I would divide both sides by 5 to get x equals 6. Pause the video and try this example. Press play when you're ready to check back for your answer. So when you combine your like terms, 9x plus x, remember there's really an imaginary 1 in front of x, so that would be 10x. And then we're going to isolate x by getting rid of the minus 7 and then dividing both sides by 10. So if we scroll down here, these types of problems we're going to be doing the distributive property. So if you look at this example here, the first thing that you would actually do is distribute the 2. Remember, you would distribute before adding because you're still following PEMDAS when you're simplifying. So you would do the multiplication before addition. So the first thing we're going to do is distribute the 2. So I'd bring down my 7x plus 2x plus 12, and then I bring down my equals 39. Now I have the same kind of problem that I have above, so I can combine my like terms to get 9x plus 12 equals 39. If I minus 12 from both sides, I get 9x equals 27, and then divide both sides by 9, x equals 3. Something to consider, if you just kind of take note of it, my equal sign for the most part, that's the thing that should be coming straight down. Your equal sign you really never want to move. You just want it to come straight down every time you work, and your problem will get kind of narrower and narrower as you go. Give this one a try. For these two, I'm going to remind you that before you start, you want to change your minuses to plus negatives, because if you look at that example right there, you can actually now see that it's a negative 7 that's being distributed and not just a 7. So be careful when you're doing this problem and this problem that you take note of that. Pause the video, try those 3, come back when you're ready to check your answer. So here the 3 got distributed, everything else came down. Working linearly, you end up with x equals 3. You can see that work and check what you have. On this one, when you distribute the negative 7, don't forget that a negative 2, or negative 7 times a negative 2, that's why that's a positive 14. This answer, just in case you can't see it, is negative 4. 12 divided by negative 3 would be negative 4. Here, you're distributing a negative 4. You should change it to plus negative, and then negative 4 times what's really a negative 3, that's where that positive 12 comes from. Skipped a couple steps here and got x equals 5. So if you looked at this first example, your gut might tell you, okay, that's pretty easy. I would distribute the 3/4, and you can absolutely do that. The problem is, since 3/4 and 6, when you multiply those, if you put the 6 over 1, the 4 and the 6 won't cancel out completely, so you're going to end up with fractions, which is okay, but there's actually an easier way to do this type of problem. So instead of multiplying by 3/4, what I'm going to do is get rid of the 3/4 by doing what we learned the other day, which is to multiply by the reciprocal. So I'm going to multiply both sides by 4/3. So you can see that your 4's would cancel and your 3's would cancel, so now you're just left with a z minus 6. And then whatever you do to one side, you have to do to the other. So I would multiply this side by 4/3. I could put my 12 over 1, and now my 3 would cancel, become a 1, 12 would become a 4, and so if I multiply across, I bring down my z minus 6, and that would equal 16. And now to solve that, I just have to add 6 to both sides, and I would get z equals 22. You absolutely could have started the problem by distributing, and in theory, if you do everything correct, you're going to get the same answer in the end. The problem is you're going to have a fraction in front of the z, and you're also going to have a fraction when you multiply by the 6. So it's just a quicker way of getting rid of the fraction is to multiply by the reciprocal at the start. So if you look at this example, I could distribute 3 over 2, or the quicker way would be to multiply both sides by 2/3. And you can kind of see that your 2's and your 3's would cancel. And then whatever you do to one side, you do to the other. So I'm just going to leave you right there. You can finish that problem, and then you can also finish these two. Pause the video, come back to check when you're done. So if you look at this example, after you multiply both sides by the reciprocal, negative 24 by 2/3 is that negative 16. It becomes a basic two-step problem. So you get rid of the 5 by minusing, you get rid of the 3 by dividing. Your final answer is x equals -7. This one you multiply both sides by 5 over 2. Again, a very basic problem once you do that. On this one, don't forget that because the fraction is negative, -4/5, its reciprocal would also be negative. So when you multiply 28 by -5/4, you end up with -35. If you add 1, -35 plus 1 is that -34, and then divide by 4. At this point, you actually just want to reduce that fraction. You can divide top and bottom by 2. It's probably going to be the quickest, easiest way. So that's where the -17 over 2 comes from. You could change that to -8 1/2. It would technically be the same, but there's really no reason to. It's just an extra step that you might make a mistake if you maybe you accidentally call it -7.5 or -9.5. So might as well just leave it as improper. If you want to give this word problem a try, go for it. We are actually going to go over this in class, definitely. But if you're able to come in with it complete, perhaps you'd be able to help another student. But if you've gotten up to this point done, you are good to go.